So for section 4.4, applications of linear systems, word problems. That left-hand page that we just completed basically is this box right here, when to choose a method, so which method is best for when. So that's kind of, you can refer to that if you didn't get to finish the left-hand side on page 47. But we're really going to be looking at just some examples. So I want to look at problem 1, finding a break-even point. In finances or business or whatever, a break-even point is the point where the cost of making something is the same as the amount of money that you earn from selling it. Does that make sense? Yeah. So it's the one single point where your expenses and your profit intersect. And then usually after that, the break-even point, your expenses are less than your profit and you're just making money. Okay? So let's read this question together, and then we're going to end up making an equation for expenses, an equation for the profit, and then we're going to find where the break-even point is. So problem 1. We have a puzzle expert who wrote a new Sudoku puzzle book. His initial costs are $864. I'm going to underline that. And binding and packaging each book costs 80 cents. So I'm going to underline that as well. The initial cost and the cost for packaging each book have to do with his expenses, right? It's how much money he is putting in order to create this, okay? So let's define some of our variables. Y is going to be the total money, and X is going to be how many books, right? Number of books. So before we even continue, let's write an equation for his expenses. Okay. His expenses are going to be Y equals what? What is his initial cost he's paying regardless of how many books he prints? $864. Plus, how much is each book costing him to make? 80 cents. So 0.80x. 80 cents per book. Okay? There's your equation for his amount of expenses. Let's read the next one. The price of the book is $2. So that means that's how much he's charging people. So he's making money on that one, right? So what is his profit? How would you write it as an equation, though? Y equals 2x. Okay, so then how would I find, the question wants to know how many copies must be sold to break even. So how can I figure out how many books he has to make or has to sell in order to break even? You guys, what type of system does this look like? Substitution, right? Plug in 2x for y. So 2x equals 864 plus 0.80x. This should make sense. Think about it. My profit equals my expenses. That's the definition of break even, right? Where my profit and my expenses are equal. So how would we solve for x? I would subtract 80 cents. And that gives me 1.2x equals 864. And then divide everything by 1.2. Oops, not x. So we would end up with x equals 720 copies, 720 books, something like that. So what this is saying is that after 720 copies have been sold, the amount of money he makes is now greater than the amount of money it costs to make them. Okay? But at 720, he broke even completely, which is what businessmen do every single day. What is the minimum amount I have to sell in order to at least break even? You want to at least break even. You don't want to lose money, okay? Problem 2, we're going to be looking at word problems, and there's a little blurb up on top. Basically, it's telling you that in real-world situations, you need to consider the constraints described in the problem in order to write equations. And then once you solve an equation, you need to consider the viability of the solution. Viability means does it make sense? For example, a solution that has a negative number of hours is not a viable solution. So when we are solving word problems using systems of equations, we have to think about, does our answer make sense? Okay? So we're actually going to skip to the biology question. So we have, in this biology question, we have a group of scientists that studied the effect of a chemical on various strains of bacteria. Strain A started with 6,000 cells and then decreased at a constant rate of 2,000 cells per hour after the chemical was applied. So we're going to let Y equal the total number of cells. And what's X going to be? Time. So number of hours. Or time in hours. Okay? So before I even read the next sentence, let's write an equation for strain A. So for strain A, our total number of cells is going to end up being, how many did we start with? 6,000. And if we are decreasing at a constant rate, what are we going to do? Subtract 2,000 cells per hour. So 2,000 X. Okay, then it says that strain B started with 2,000 cells and decreased at a constant rate of 1,000 cells per hour after the chemical was applied. So B is Y equals 2,000 minus 1,000X. The question is, when will the strains have the same number of cells? So if I want my strains to have the same number of cells, what am I going to do with these two equations? Same thing we did on the last one. We're going to set them equal to each other, or we're going to use substitution. So that is 2,000, and I would move over your work to the left just a smidge so that we have enough room, minus 1,000X equals 6,000 minus 2,000X. So basically, I just substituted. Okay, you can go whichever way you wish in solving this. I'm going to add 2,000X. So then my X's become positive. And is everybody okay if I also subtract this 2,000 in the same step? Okay. So that's going to give me 1,000X equals 4,000. And then how do I solve for X? Divide by 1,000. So then X equals 4. 4 what? Hours. Okay. Now, with word problems, though, we need to double check that this answer makes sense. Does 4 hours seem like it makes sense right now? Okay. How many cells will we have after 4 hours? So let's plug this back in just to double check. Where are we going to plug this in, guys? Do you want to plug into A or into B? A? Okay, so that's Y equals 6,000 minus 2,000 times 4, because after 4 hours, so that's Y equals 6,000 minus, what's 2,000 times 4? 8,000. So Y equals what? Negative 2,000 cells. Does that make sense? Can we have negative cells? No. So when these two become equal, it's after 4 hours. But after 4 hours, they'll all have 2,000 cells. So by the time one of them eliminates all the cells, has the other one even caught up yet? So will they ever have the same number of cells? No. So this solution does not make sense. So we could say they will never have the same number of cells. Okay? Until they all reach 0. But according to our equation, they'll only catch up with each other after 4 hours. And after 4 hours, we've already run out of cells. Okay? So they will never catch up. So the last one, example 3, we're going to solve, this one's a current problem. So let's read the problem. You row upstream at a speed of 2 miles per hour. You travel the same distance downstream at a speed of 5 miles per hour. What would be your rowing speed in still water? So that's what we want to solve for. So let's call it S. And S is going to be my speed in still water. What would my other variable be? So I'm trying to figure out my speed in still water. I know what my speed is when I'm going upstream, which is against the current. And I know what my speed is when I'm going downstream, which is with the current. What do I not know? Who said it? The speed of the current. So let's call that C. So C is going to be the speed of the current. Okay? So let's write an equation. If I'm going upstream, is my current working with me or against me? Against me. So that's going to be my speed in still water. And if the current is working against me, I'm going to subtract the current speed. And the problem told me that that should come out to how fast? 2 miles per hour. Now, we are assuming that you are rowing at the same speed. So to go downstream, I have my current speed, or my still water speed. And then is the current helping me or working against me when I'm going downstream? So it's helping me, so we're adding the current speed. And that should come out to what? 5. What method would you use here?
Elimination.
Yeah, because look, the C's are already all set to eliminate. So S plus S gives me 2S. Negative C plus C eliminates, equals 7. And then divide by 2. So what does your still water speed come out to? 3.5 miles per hour. So that answered part of the question. How would I find out the speed of the current? Yeah, plug it back in. So I'm going to do 3.5 plus C equals 5. Subtract 3.5. And I get C equals 1.5 miles per hour. Okay? There's a bunch of other problems similar to this, like when you're flying in an airplane, you have a headwind, which means it's going against you. A tailwind means it's helping you, so it's coming on your tail. A headwind means it's coming on your head, so against you. Okay? But all the problems are very similar to that. Part B gives you your rowing speed in still water and the speed of the current. So then it wants you to work backwards. So I'm sure you guys can figure that out. You will be fine. But now we've at least done one like that. Okay?